So this is the solution to the second problem in the first tutorial. Find the average velocity in the time interval t is equal to 1.5 seconds to t is equal to 4 seconds. The average velocity is defined as the displacement, delta x, divided by the time elapsed, delta t, and that is equal to the final position minus the initial position divided by the final time minus the initial time. So we have to identify each one of those factors. So at t is equal to 1.5 seconds, right, the position is equal to about 8.25. So we have t initial is equal to 1.5 seconds, and we have the final position, the initial position is equal to 8.25 meters. And that's just an approximation, and when you have to read off the graph you might not get much more accurate than that. It's a little bit easier for this next point. Alright, when t is equal to 4 seconds, so tf is equal to 4 seconds, when tf is equal to 4 seconds, then the final position is equal to 2 meters. And once again, when you're reading off the graph, you have to make a reasonable estimate of what the value is if the scale's not fine enough. So now we've got the initial and final positions, the initial and final times, so we can calculate the average velocity, which is the final position, 2, minus the initial position, 8.25, divided by the final time minus the initial time, 1.5. So that's minus 6.25 divided by 2.5, and that's equal to minus 2.5 meters per second. So the average velocity between 1.5 and t is equal to 4 seconds is minus 2.5 meters. Part B is determine the instantaneous velocity, and we use the definition of instantaneous velocity, the limit as delta t goes to 0 of displacement over time. Delta x over t is a velocity, of course, and delta t heads towards 0. This just means find the slope of the tangent to the curve at the time of interest, and you need, so there's our, so the point of interest, right, is here at about t is equal to 2 seconds, and the blue line there is a tangent to the curve, so we need to find the slope of this blue line. And when you're doing that, always take 2 points, and of course if you're taking it from a graph, make sure they're far apart. We could also, for example, find the slope of this line representing the time slope at about t is equal to 5.2. So we've taken our points. We're going to take the initial time as equal to 0, and that means that x will equal to 13.25, sorry, 13.1, and now the final time is equal to 3.5 seconds, and the final position we see is xf equals 0. That means that we have velocity, the instantaneous velocity is 0 minus 13.1 divided by 3.5 minus 0, and that's equal to minus 13.1 on 3.5, and that's equal to minus 3.7 3.7 meters per second. So now at what value is the velocity equal to 0? Well, the velocity is 0 when the slope of the tangent to the curve, is 0. So that's at this point here, right, at about t is equal to 4 seconds. Right, we can draw our tangent. It's a line with 0 slope. Right, so that's the tangent to the curve at t equals 4 seconds. So the velocity is 0 when t is equal to 4 seconds. So that's it. That's how each one of these can be solved. All right, we find the average velocity,